Section 1.3 is on page 22. Talks about lines in the plane and slopes. I'm going to split this into two parts. So the first part is going to be finding the slope and graphing, and the second line would be finding an equation of a line. When I say two parts, I mean 2 lectures. So if I take the first lecture, that's better. There we go, nicer. So to find an equation of a line, we have one of 5 cases all throughout. Given a graph, to find an equation of a line, M is denoted by the slope. So given a graph, if I want to find the slope of a line, I would say it's rise over 1. Keep in mind, rise up is positive, down is negative, and 1 is left to right. Right is positive, left negative. I'm going to give you an example on each of those. So if I'm given a graph and I want to find the slope, I pick any 2 points on the graph. It's always left to right. How many units do I rise from one point to line up with the second, which means up or down, and 1 left to right? I could be asked to find a slope of a line given 2 points. If I'm given 2 points, I label the first point x1, y1, and I label the second point x2, y2. And the slope will be y2 minus y1 over x2 minus x1 in that specific order. If I'm given an equation, that's the third case scenario. I'm given an equation and I'm asked to find the slope of a line. I solve for y. I get y by itself on one side, everything else on the other side. And when I do that, this is what's known as the slope-intercept form. Very important form. Most books ask for it. And the reason for that, the number in front of x would be my slope, and there's an added bonus. If I let x equal 0 right there, I'll get y to be b, which is the y-intercept. That's a point on the graph. And I'll talk about what that means as soon as we get to the examples. Why is that important? We have 2 special cases. Even though they're special cases, they arise a lot more than you like. Special case 1. If you have a vertical line, and a vertical line really runs up and down, you should know automatically that the slope is undefined. And if you look at the equation that's given, it's normally x equal a number. Y is not present. In any equation of a line, there's an x and a y. That line is oblique. That's a line that's not vertical nor horizontal. The 2 exceptions would be the vertical line and the horizontal line. One of them happen when y is not present, which means x is there. And the second special case, which is a horizontal line, that's when you look at y equal a number, x is not present, and the slope of that line is always 0. Those special cases you need to know. So I'm going to start with the beginning, and I'll keep on reminding you of this. I'm looking at page 31 in our book, Estimate the Slope of the Line. They gave me a graph. So what I do, I need to pick 2 points on the graph and use rise over 1. The slope is, given a graph, rise over 1. And that would be, and let's see, 2 points. This seems to be a point. And any other point, this is a point right there. Any other point will do. You could pick this, it doesn't matter. Don't you rise 1 unit up? Since you're going up, it's positive and it's 1 unit. And don't you run 1 unit to the right? Since you're running to the right, it's 1 unit. So the slope in this case is a 1 over 1, which is 1. And any questions? So anything you have, any confusions you have, you are welcome to bring it to class and say, you know what, I looked at number 2, what you did, and I had a question on it, but since you can't ask me on the video, you could ask me in class. Anything you have, say for the class. I look at number 4 on page 31. I need 2 points on the graph. Well, there's a point right there. I need another point. This point, I'm not going to guess what that is, so that's unwise. I should pick a point that's passing through the edges of those squares. It seems this is one right there. There's another one. There's any one of those will do. So if I look at the slope, and that is rise over run, I'm gonna rise 1 unit, but I'm rising 1 unit down. Down is negative, and I'm running 2 units, right? This is labeled 1, 2. 2 units to the right. So the slope in this case is negative 1/2. Now, nobody is stopping you. You could do this. You could say, you know what? This is the 0.06. This is the 0.25. And nobody could stop you from using this formula. But you should know all three. You should be able to find the slope given whatever scenario you're in. If they give me a graph, rise over run is the best way to do this. Or the most efficient way, I should say. Not the best. Okay, how about given an equation? Well, number 6, it says, find the slope and the y-intercept, if possible, of the equation of a line. What do you know about equation of a line? We solve for y, right there. That's case C. We solve for y. Well, guess what? Number 6, they already solved for y. If they solve for y, the number in front of x is the slope. And the y-intercept, you always put that as 0 for x. If you put 0 for x right there, don't you get a 3? Or you could just read it off right there. Now you want to be a bit careful with this, not to rush and mess up an easy problem. You know, rushing is not a good thing. So if I look at this problem, they're asking for the slope. You might be tempted to say it's the number in front of x, but do you see that you don't have a y on one side? So what you're going to do, you're going to solve for y. You're going to move the 2x to the right. And you're going to divide by a negative 3 each of those. And you're going to get y to equal 2 over 3x. Oops, I don't like that 2. Minus 8. Now that I have y on one side, I could say the slope is 2 over 3. And the y-intercept is actually 0. I'm going to say here, the slope is 2 over 3. And the y-intercept is going to be 0, negative 8. And I should circle or box those. That would be wise for me to know what they're doing. Alright, and if I look at this problem, x plus 5 equals 0. If I solve, well, there's no y to solve for. X equal negative 5. I recognize that this is a special case. How do I know that? X equal a number. What's the slope? The slope is undefined. Not only that, I am aware, you don't have to graph this, but I am aware that this is a vertical line at x equal negative 5. And do you see that could never ever cross the x-axis? The y-axis? That's why they say, if possible, no y-intercept. And how about this line? Well, if I solve for y, there is a y equal negative 1. Well, it might look confusing. Can't I rewrite this as y equal 0 times x minus 1? Or I could recognize that that's the special case. If you have y equal a number, what's the slope? The slope is 0. And to show you how this graph looked like, again, if you could graph any problem, pretty much the graph gives the answer away. Pretty much. If I look at y equal negative 1, this is y equal negative 1. Can you guess where does the y-axis happen, y-intercept happen? The y-intercept, if I let x equal any value, isn't y always a negative 1? Alright. How about if I wanted to find the slope given 2 points? Now again, nobody's stopping you from plotting those points, not recommended, and using rise over 1, not recommended. You should be able to find the slope with any situation, so you shouldn't focus on one way more than the other. You should, if I gave you a graph, use rise over 1. If I gave you an equation, solve for y. And if I gave you 2 points, use y2 minus y1 over x2 minus x1. So since I'm given 2 points, I would say this is point 1 and this is point 2. y2 minus y1 over x2 minus x1. So the slope would be 5 y2 minus 0 over 1 minus a negative 1. Wouldn't that be a 5 over 1 plus 1? The slope in this case is 5 halves. And that's all they want here. Find the slope through the given line. And how about if I wanted to do number 32? The same deal. You'll notice here it's kind of annoying to sketch a graph of this. It's easier to use algebra. It's a bit more work. y2 minus y1 over x2 minus x1. The slope is a negative 10, that's y2, minus y1, which is a negative 2. You know what? Over x2 is 11 over 3, minus x1, which is 11 over 3. I'll get the slope to be negative 10 plus 2 is negative 8. 11 thirds minus 11 thirds is a 0. The slope is undefined. What does this tell me? This tells me this is a vertical line. Let me see if I could do one more. Seems there is time to do one more. Let me get one more going. I'm going to do number 36. Again, the slope is y2 minus y1 over x2 minus x1. The slope is y2 is negative 3 minus y1, which is negative 13, over x2, which is a negative 2, minus x1, which is a 3. And the slope would be negative 3 plus 13 is a 10. And negative 2 minus 3 is a negative 5. So the slope would be 10 divided by negative 5 is a negative 2. There it is. Not that bad. Now, find the slope given those 5 cases. We touched on each of those. Let's talk about the last portion that I wanted to look at. I'd like to sketch a graph of a line. To sketch a graph of a line, I need 2 points because it is a linear equation. That's what's so special about a linear equation. Linear equation is an equation in which the power and the variables equal exactly 1. No two variables are multiplied or divided by each other. What's so special about a linear equation? If you look at the graph of a linear equation, it's the only straight line in math. What that means, I only need 2 points. If they tell me y equal negative 4, now, do you see that y equal negative 4, y equal a number, is a special case? Isn't that automatically a horizontal line? What does that mean? That means I could go to y equal, this is the y-axis, to y equal negative 1, negative 2, negative 3, negative 4, and just put a line through it. And there it is. Now, if this was an algebra class, I would have explained this a lot more in details, picked points, and did all of that. But since this is review, hopefully you remember that. So every time you label those, make sure you tell me where the original is and where the line is. So graphing a line is really simple if you could find the 2 points. How do you find the 2 points? That's what we're doing. Notice that this line is written in slope-intercept form. I need 2 points. Isn't 0, negative 2 an actual point on the graph? That's a point. And isn't the slope 3 over 1? So doesn't that mean I could rise 3 units, rise 1, 2, 3, and run 1 unit, and I should get another point? What if I want another point? Rise 3 units and run 1 unit. You could do that as many times as you like, and you can get as many points as, you know what, that wasn't scaled properly. You know, I should have centered that. I didn't. That's my mistake. Let me center that right on the grid. I thought I did, but it's slightly off. So if I put it right, a bit more, just a bit more. It's kind of hard to do that once you set it. Otherwise the graph will be slightly off. So now if I look at this, say, okay, the first point was 0, -2. I'm going to rise 3 units, 1, 2, 3 units, and I'm going to run 1 unit. And if I rise 1, 2, 3 units and run 1 unit, and if I connect those with a straight edge, guess what? Those should fit on the straight line. That's why you need to use a ruler when you're doing this. So since my grid was off, there it is. What if I am given this form? I have two options. I could solve for y and use what I just did. Or if I have, this is called standard form or general form, I think. Standard or general. If I look for the intercepts, if I let x equal 0, if this is not there, doesn't that mean 5y equal 20 or y equal 4? That's 1 point. 0, 1, 2, 3, 4. And now if I go in and reverse the order, I say, okay, what if I let y equal 0? If 4x equal 20, divide by 4 both sides, x would be a 5. 1, 2, 3, 4, 5. Connect that with a straight edge. There's my line. You could definitely, if you wish, you could solve this for y. You could say, well, move this over. 5y equals -4x plus 20. Divide by 5. -4 over 5x plus 4. Wouldn't you say the y-intercept is 4? Don't you rise 4 units down? 1, 2, 3, 4. And you run 5. 1, 2, 3, 4, 5. Do you see you get the same line? You can't get it wrong. And what if I have it in this form? I think this is standard form, this is general form. Same deal. You have multiple options. You could solve it for y. You could solve this equation for. You could say, you know what, if x equals 0, what do you get? You will get 2y plus 10 equals 0. 2y equal -10. Y equals a -5. I got 1 point on the graph. 0, -1, -2, -3, -4, -5. If I set y equal to 0, I'll get x plus 10 equal to 0. That means x equal a -10. If I say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're going to talk about rescaling later on. If I connect those with a straight edge, there is my line. And if I see x equal 2, isn't x equal a number a vertical line? Right there, that's a special case. So I would go to x equal 2. X equal 2 is right there. And I will draw a vertical line, and that's the end of it. I should put arrows on those because those are infinite. They never stop. And let me give you the homework on this.